Hi, my name is Vahan Davoudian. I'm a physics experimentalist for 30 years, and today we talk about general relativity simplified. I cannot start from 100 years when Einstein started. I have to go back 500 years when Copernicus started this. And there's a long history, but I make it short. One of the greatest minds in the history of astronomy and physics was Copernicus. Before Copernicus, they were thinking that, the center of the universe is Earth, but I was absolutely wrong, and so many astronomers like Tycho Brahe and everyone else believed in that, but Kepler was the only one who was following Copernicus, because Copernicus solved the problem forever. And then on his desk, how he did it, I don't know. He changed or replaced the sun with Earth and then solved the problem. And since then, it's been 500 years, we have no problem, because that is the way it is. Anyway, he was amazing astronomer, and in fact, when you go back like 500 years, you can see the relativity starts from that great mind in astronomy, Copernicus. He said, our perception of universe, our perception of our surrounding, or solar system, or anything, it depends on where we are. And that is absolutely right. That means that is relativity. Well, in fact, that relativity has a definition. I tell you exactly how it is. A condition in which the existence or importance of entity depends on another. Or in other words, in a simple language, relativity means you're comparing. I cannot tell, I'm walking 3 miles per hour. What is my frame of reference? It's Earth. So always you are comparing to something. And I have so many posters, so many experiments, and this is part 3. I've already talked about part 1 and part 2, and then this is part 3. So I will explain each of these experiments, which was done with great physicist, great astronomer, and then you can see my idea was that overall the concept of gravity is imbalance of charges. And one more thing I'd like to add. I want to thank YouTube. YouTube does amazing job. They're so comprehensive. I appreciate what they do. I think YouTube is the key to learn, because I compared YouTube to synapses in a human's brain. Synapse is like a junction. It's connecting billions of neurons together. And that's exactly what YouTube is doing. And that is phenomenal. That is so good. And I just want to thank them, because they are like internet. They're connecting everyone together. Like, I am physics experimentalist. I just put my, upload my theories. Some other people do that, and then we can see who does what, and we can exchange views, we can even learn. So that is the key to learn, and I just wanted to thank. And I think this is what YouTube does. It's so amazing, because this is the way they are promoting science. Because my objective is not making, how many subscriptions or what. My main purpose or objective is, to teach science as much as I can, because I have 30 years experience. So, this one I missed on part 2, because on part 2 I explained on Earth we have differential forces. Whatever you suspend in northern hemisphere, I'm not talking about, thick wire, like a string, it is going to go counterclockwise. It will rotate counterclockwise. And then if you go to southern hemisphere, it's going to be clockwise. Anyway, I was trying to convince, in universities, and finally I could convince 50% of them, but I didn't care, because this is absolutely true. And then cyclotrons always on the northern hemisphere is going counterclockwise, and southern hemisphere is going to clockwise. And then even if you launch a supply for a space station, always you go toward the east because it gives a boost. And then another example is merry-go-round. Coriolis effect and the differential forces always causing torque on everything which is suspended. The reason why we don't we don't see it, because we are traveling with the earth. Someone, a young student, asked Albert Einstein, why we don't feel the earth rotation? The answer was so simple. The answer was so good. He said, because you, me, and the other students, we are traveling with the earth. And that answer from Albert Einstein was absolutely right. So on my second one, I proved that pendulum is one of the greatest inventions in the history of mankind. It's a harmonic oscillator. Then I proved that, what Mr. Foucault did was so good, and then while the pendulum is going back and forth, swinging back and forth, Earth is not waiting for them. It's going underneath, it's rotating. Anyway, so this is another one experiment, and he was amazing Austrian physicist, and then he proved that, on northern hemisphere is always, differential force is causing counterclockwise. This is kind of unique experiment because he had a huge tank like this, and it's exactly 5 meters long and 2 meter deep. Then he let the water stay for 2 days, and then he had to put some styrofoam, which they float on the water. And then this is called conservation of angular momentum caused by Earth's differential and Coriolis forces with a huge tank of water. Well, of course, I have to explain, Coriolis is not that much, but mostly it's Earth's differential, because I remember I was trying to convince some university astronomers. I said, what, think about that. On Falkland and World War, and England was fighting with Argentina, then what happened? They were throwing shells because shell goes like 60, 70 kilometers, and at that time it's almost like free falling, and it's going to go parabolic or something like that. And you know what? They had no idea, because English people never fought in the southern hemisphere. Instead of throwing in exactly where the shell was supposed to land, it was landing in different place. Well, of course, I could convince some of these, people, and they love this idea. I said, this is the way it is. And then, I had like bowling ball and everything else. So he let this water stay for 2 days, and then gradually he opened this valve. So the way this valve is, you see the difference. It's 500 centimeters divided by 5 centimeters is 100 times more. You see, it's like Earth is causing a small thing torque, and imagine 500 times. After a few minutes, he saw gradually the styrofoam is going counterclockwise. And there is no way that you can tell that the differential force does not exist. It does exist, but like I said, I have more experiments, and then I will prove it. And this one is Henry Cavendish, and he was one of the greatest. Let me put this back. English people are so smart in this matter. They wanted to see how the Earth, the weight, density, and everything else. Well, his name was John Mitchell. He was a good geologist, but unfortunately he passed away. So they could find Henry Cavendish. Henry Cavendish is an amazing scientist. And in fact, if you go in history and ask people, Michael Faraday and Henry Cavendish are the best experimentalists. He was 70 years old almost. And the weird thing about this, and no one has done in history like this, he repeated this experiment 29 times. Well, it doesn't matter, because he was so careful. So let me show you exactly what he did. So he had these balls. You see, that sphere is exactly 158 kilogram, and the smaller one is 730. But Sir Isaac Newton could see like 100 years ahead, and he never ever conducted any experiment for this. Sir Isaac Newton, M1, M2 divided by R2. He never did, but he was absolutely right. And imagine, he never did anything for this M1, M2, and even, his cannonball, he didn't do that. It was a thought experiment. If you go on the top of the hill or mountain and give it more velocity, it's going to go around the Earth. And Sir Isaac Newton was right. 200 years. Now we have a space station. It's exactly like Sir Isaac Newton cannonball is going around there in 90 minutes. And then we do amazing experiment that we could not do it in space because it's microgravity. We don't even need to go in space. I mean, the space station does everything. So he did this, and imagine, this is my idea. I think I don't accept Sir Isaac Newton's formula in this case. Mostly I go with the French genius, Mr. Charles Coulomb. And it's a Q1, Q2, R2. And imagine how shocking these are closed. That's exactly the same thing. So think about that. These are both lead. Lead is a real bad conductor. So is this one. And imagine, he did this in the closed environment, and then he was so careful because he was good experimentalist. You see, there is a, eyepiece over there, like, camera. It wasn't camera, but he could look through this, and the poor man was so good he could not even breathe. So he just did not want anything interfere with this, and absolutely right. In science, they said if you want to do experiment, it must be thermodynamically closed. I have to explain it a little bit. It's a little bit complicated. In other words, in a simple language, says if you do any experiment, you should not do anything like an air, there's so much friction. I mean, we can't do it. See, I'm doing my pendulum. It's in air. I cannot pay $100,000 and put a vacuum here. So anyway, he did this, and after a few days, he realized this small ball, a small sphere, lead was 730 grams, was attracted toward the 158. And my analogy, my logical analysis is, they're both lead, they're both conductor, and they're both attracted to the center of the Earth. So where was the gravity? Why this small one attracted to big one, 4.2 millimeters? And let me tell you something. 4.2 millimeters in astronomy is light year. So that's the way he did, and then I'm glad he did this. And he is Miguel Alcubierre, and it's just an amazing coincidence. It was 1994. I will explain what happened in Universal Studio. So he came up with this idea, which is fabulous. Why? Because I am 70 years old. I know exactly these things can happen. When Yuri Gagarin went to space, I was like 10 years old, and then I was so excited. And then I used to read a lot of books. Jules Verne was my, best friend. I love it. It was exaggeration, of course. But what Jules Verne said, you could see 100 years ahead. He said people will go on planets. And that's exactly what happened. That's exactly what happened. So, Mr. Alcubierre said, we will have a drive. So instead of propulsion, let's think this is like an airplane. You have to have propeller, you have to have jet engine, then it will do action, reaction, and go forward. He said instead of that, your spacecraft is not going to move. A space moves. And that was an amazing idea. So in other words, he said, this part will contract a little bit, and this part will expand. So it will push it forward. And that's the way he said, expanding and contracting the space-time. And which, imagine if one day this happened, it's going to be breakthrough in science. Then it says that displaces the central region, changing the geometry of space by creating wave that would cause the fabric of the space expand and contract. Albert Einstein one time said it's the happiest moment of my life, and this was also the happiest moment of my life because, let me show you, I was in Universal Studio. Probably these things happen to people once in a million. But I don't know why. I remember the exact circumstances. It was 1994. We were in Los Angeles, and then with the kids we went to Universal Studio. My son and my daughter, they were so excited. They said, "Daddy, we have to see what this is." Because they read a little bit, but they could not understand. I read about it. I could understand almost most of it, but I wasn't sure exactly how that was. But why do I always, have a good memory? Why do I remember exactly what happened? So anyway, we were in line, and then it took 2 hours, and then by the time we get there, it was so exciting, and then we had also company, we invited them. Anyway, after like few minutes, there was a malfunction, and then they had to stop the carts and everything else. And then I don't know why, I just happened to be there. They opened one panel, I could see the cart. So there was a cart there, so you sit on that, I think 2 people or 3 people can see. So that cart has a chain underneath, so it goes up and down, left and right. So in other words, it's doing all kind of, inertia things. And then I said, wow, that is what it is. When you think that you are going in a lava tube, that's exactly what happened. I think whoever did the engineering, they must be genius. It was the best engineering I've ever seen in my life, because we went through the lava tube, and guess what? Our cart was going steep. We could see that, chain, and the synchronization between the light and the cart was 100%. Even though I knew that it's an optical illusion, but my kids were screaming. I said, "Don't worry about that, we'll survive." So I said, what will happen if this happens in a real life? See, I am not propelling my car, my surrounding, my space is moving. So anyway, that was the same year Mr. El-Kibir said. Then I read his book and his thing, and then I realized Mr. El-Kibir has a fantastic idea. These things can happen. And sometimes, unfortunately, things happen is beyond our imagination. I always keep up with this science. This is one of those phenomena. It never happened in history. It might, but Mr. Bruce Kernan, English pilot, he was 20 years old, and this is the picture. They just happened to be there, they were flying from Bermuda to Florida. And then, I don't know what happened, they got stuck in a fog. It was negative charges, extremely powerful. Why? Because he said everything was malfunctioning, the compass, navigation. They were disoriented, they had no idea what happened. And then when I compared this with new Back to the Future, I know that's exactly what happened. Where is the gravity? Because he landed on Florida almost 40 minutes early. And then how could a small airplane, which goes almost like 180 miles, go almost like 380, 400. So that fog was negative charge. It just defies the laws of gravity. So always, I think there are some exceptions that things happen, but unfortunately, they just happen to be at the right time in the right place, and then here, did so many books, and then I love those books. I read that, and this is the one it's showing. And he says they were out of control. They had no idea how fast they were going, and it was like a vortex. So they were inside the vortex, and they were going so fast. They had no idea what they were doing. This is another poster. As you know, James Clerk Maxwell, exactly like Sir Isaac Newton, is one of the greatest minds in history. I mean, every morning I get up and say, thank you, Mr. James Clerk Maxwell. You have the electromagnetic wave. Like to talk to people, like to go online. And what James Clerk Maxwell did was beyond our imagination. How he could discover electromagnetic wave. Our entire life depends on electron. We can, call Moon, we can call Jupiter, we can call Mars. Well, of course it's time. We can call people on the other side, China, Japan. But see how amazing it is. I mean, like 50, 60 years ago, these things never existed. Never existed. So Maxwell did this, and just want you to pay attention. These are exactly trampoline or line of force, like general relativity said. They said if you have a ball like this, like Earth or whatever, it's causing dent in the fabric of the universe. And Maxwell did exactly the same thing. But instead of mass, Maxwell put a current-carrying wire. Oh, what I mean, Maxwell knew about the gravity. And then he sent this to Michael Faraday. Michael Faraday was so thrilled. Well, of course, the poor man didn't have high education, but he was a good experimentalist and explained, Michael, this is the way when you're talking about line of forces. These are line of forces. And I think James Clerk Maxwell was right. And we owe it to him what he did for, discovering the electromagnetic waves was beyond my imagination. Unfortunately, I am not implying or I'm not suggesting I am, overthrowing Albert Einstein's idea. No, he is my boss. He is the best. But you know what? Everyone is entitled for his or her, opinion, or entitled for their opinion. So I think that the electrostatic, charges and the electromagnetic are the main cause for the gravity. So how could I prove this? And I remember one time he was working in a patent office, and then he said, yeah, if somebody is falling from this building, they don't feel their weight. And Mr. Einstein, it's obvious, because there is no action-reaction. The only way in a universe you can feel your weight, you have to have action-reaction. If I'm in a space station, I'm free falling. How do I know how much do I weigh? So they change my acceleration. They just give me a jolt. Then I say, wow, this man is 80 kilograms. So I came up with this idea, and unfortunately, some people, they said, it's a hypothetical, it might not be true. I said, no, it is true. Imagine I am jumping from 100 meters with a bungee cord. But imagine if my glasses come off, if my watch comes off, it's not going to pass me, it's going to go with me. At the same time, I'm so careful. There's 10 kilogram and 1 kilogram. But they are free falling, but it does not show, if you put a scale underneath, it doesn't show any acceleration whatsoever. So I said, if you push the 1 kilogram, I need less force to accelerate, 10 kilogram, I need more. And this is absolutely true. And if you do that, you can see what happened. And then I came up with this experiment, which you have to be extremely fast. And imagine if you throw a steel ball from 100 meters, it might take 9 seconds or 10 seconds. But I said, if you are going with this scale and this with this plastic and 1 kilogram, you are exactly going the same way. I mean, you're free falling, but there is a string over here, and then I'm holding that string, but I'm not pulling. As I fall maybe like 10 meters, I can push this string and give a jolt, and immediately that scale shows 1 kilogram. And you know, when I said this in Caltech, they were so thrilled. You know, they got a big kick out of it. They said, that's fantastic. But unfortunately, I cannot do this. I cannot, you know, I have a phobia from jumping anyway. But you know, it has to be somewhere. You can go to Magic Mountain, yeah, you can go to bungee or whatever. This is the way you can prove it. Well, of course, I have more, and then I'll show you guys. This is another experiment. Albert Einstein never did this, but it does make sense. It says your spacecraft is just here, and then he lights a shine from this hole to this hole, it goes straight. But the thing is, this spaceship is stationary, and then the astronaut is standing. The reason why it's stationary is in Earth's gravitational field. But when the same ship is accelerating, the light will bend. Well, of course, they never did this experiment anyway. I will get to Miss Amélie du Châtelet because she was the one who came up with the kinetic energy. Anyway, just wanted to prove that the gravity is not playing any role. See, I got Moon, Mars, Earth, and Jupiter. And you know, I did this with great precision. It took me months and months. I calculated the kinetic energy and everything else. And then I came up with the idea that, you know what, the proportionality on Moon is the same, Mars is the same, Earth is the same, Jupiter is the same. It's just proportional. So the main force to propelling the steel ball, or you know, the falling ball, is not gravity. It's the kinetic energy. I will explain in a minute. This is my favorite subject. Her name was Amélie du Châtelet, and like Michael Faraday, she didn't have college education, but self-study, and then self-educated. But she was brilliant. She was one of the greatest ideas, greatest physicists in history. I mean, how could someone with no education argue with Sir Isaac Newton, one of the greatest minds in history? But she did. Okay. Now I'm comparing Newton's M1, M2, Charles Coulomb Q1, Q2, and then R2, and then Albert Einstein EMC squared, and then Amélie du Châtelet, kinetic energy. And to be honest with you, we never use this formula every day. But in our daily life, always we use this formula. Kinetic energy, half mass times velocity squared. So, she was so genius, and then she had to correct Sir Isaac Newton, because what Sir Isaac Newton said is E is equal mv, which is for momentum. And then she argued, even though Sir Isaac Newton was not allowed, she argued and said, no, that is not right. It's supposed to be mv squared. And I just don't know what happened. The second husband was so genius, is Mr. Voltaire. He was a scientist. He just happened to be in Holland, and then they saw an experiment which proved this, and they solved the problem forever. Before that, they were thinking if you have the velocity 1 meter, if you drop a ball and then your velocity is 2 meters, it's going to be 2 meters. But Mr. William Gravesonde from Holland proved it's otherwise. if your velocity is doubled, the ball penetrates in clay or flour or sugar or whatever 4 times. See exactly what happened? This is 2 times, it's going to be 2 times. This is 2 times, it's going to be 4 times. So she was right. Then Voltaire came home and then told her this is the way they did in Holland, and she was so, imagine, so prepared. Because I remember Louis Pasteur said one thing, golden rule. It says, chance only favors the prepared mind. Her mind was prepared. And then she solved the problem. Well, of course, I have to mention this. Half was added. But always we use this kinetic energy, like I said. Every time we throw a ball, we just leave the ball from 100 meters, it's going to go down. The first thing, the second, kinetic energy increases. And you know what? I am not saying, please don't misunderstood me, she or he plagiarized. No, there is no plagiarism, nothing. So what she did, she continued Sir Isaac Newton's work. She did not plagiarize. Sometimes it's a misconception. What she did, she expanded, because I'm glad they did. Galileo proved something amazing. You have to disagree with scientists, and he did it, and he solved the 2,000 years, thing for. And then he said, Sir Isaac Newton was different, and like I remember. So, she solved the problem, and I'm not implying that he get it from Emily, but you see the amazing thing. But I have to say something. At that time, like 200 years before, 100 years before, there was no atom, there was no electron, nothing. And she has no idea about EMC square or what the atomic structure is. But what I mean, Albert Einstein was so lucky, and then I tell you by the end why he was so lucky. He was surrounded by the best friends, Gaussman, mathematician, and the other guys, all physicists, and then they were getting in a coffee shop, always talking about physics. So what I mean, these two are so shocking. But now we use this a lot. And this is a funny one, because I remember when I was in high school, I used to call Albert Einstein, I said, synapse. So my physics teacher asked, what is this synapse? I said, it's in a human brain, and it's like a junction. It's connecting billions of neurons, and then they love this idea, and then they give me a good grade, and that was my job, to write about the Sigmund Freud, Charles Darwin, and then Niels Bohr, Albert Einstein, and Werner von Braun for the space, and then I called him Mr. Synapse. And then my teacher asked why. I said, because this guy is extremely clever. I'm not implying he was copying. He was extremely clever. He was connecting the dots. With every time there was an invention or new thing in science, he knew that. So James Clerk Maxwell in 1864, light as a transverse electromagnetic wave. What James Clerk Maxwell did, he just made the distances short for us. But Albert Einstein had this special ability, and he was a good writer. He could write to anyone and then do, just keep connection, because he was almost informed of everything. And imagine at that time there was no internet, no electricity, nothing. But this is Michael Faraday, and he was genius. And his boss, Sir Humphrey, wanted to get rid of him. And the poor man had no idea they were conspiring to get rid of him. They said, you know what, Michael, you have to go to brick factory, to glass factory. And Michael Faraday said, I'm not interested. I have no clue for the glass. Anyway, they forced him to go in a glass factory because one time Sir Humphrey heard that, he is surpassing his master. Because Sir Humphrey was amazing. But imagine he was the boss. He didn't want. Michael was the helper anyway. So what he did, Michael changed the whole world. But I tell you why. So when he came home, he brought this brick. It was a glass brick. And he did exactly what Galileo did. Why Galileo solved the biggest problem for the motion? Because he slowed down. I followed exactly the same thing. I have no idea what his acceleration was, but Vahan's ramp was 20 times less than gravity, and the other ramp was 10 times. So exactly Michael Faraday did, because as you know, when light goes through from one medium to the other, it slows down. So we got air here, and it's obvious when it goes in a glass, it's going to slow down. And he was so genius, he put this extremely strong magnet. He wanted to see if they interact. And then this is so famous, this experiment called rotation. And then we realized this line is tilted. So what happened when this magnet was turned on, even though this was glass, but there was an interaction between electromagnetic wave or light with magnet. And it's so amazing. He laid the foundation for Albert Einstein. Because Albert Einstein loved this man. He will always mention his name. He laid the foundation for general relativity. And then imagine, this is interaction between light, electromagnetic, and magnet. This is also for Albert Einstein. Unfortunately, what they say, when you fall, you don't feel your weight, and it's obvious. So what I did, it's just so unique, this experiment. I'll show you. See? And I used to work in Golden. We had a huge warehouse, 15-meter high. And then I could do all kind of experiment, and I was free. They gave me, pass to do everything, whatever I wanted. See, if I have this, see what happened. See, because one side is heavier. The reason why this has a weight. But when I do it like this, see what happens. When I drop it oblique, it's going to go down. Well, of course, this is only 2 meters. It's not going to show. When I drop it oblique, see, did you see what happened? This is round, right? If I drop it oblique, it's going to go down oblique. See? Because I proved this with great precision, and then even I had to go by accelerometer. When you drop that, it's not going to register anything. It's going to be zero anyway. So and this is so amazing, because this was my childhood, and I don't know why, sometimes you have to go back in history or reverse engineering to find out exactly what happened. When I was a kid, I remember I loved lights. Not as good as Albert anyway, but I would just close my eyes and then look at the, a small light bulbs. And then one day I noticed something strange. I said, in my retina, I am seeing rainbow. I said, what is that? I had no idea. I was maybe 10 years old, I didn't know. And then I came to the United States, I studied electronic, and then I had a physicist friend, we went to physics classes, and I learned that, hey, what I saw is a rainbow. I said, wow. Is that rainbow? But your eyes must be real close. I mean, you can do both. And then imagine you have a reflection from a small place, you know, like a shiny place, or you have a reflection any place. So it will help you when you close your eyes on your retina. You can see those electromagnetic waves are just woven. It's exactly like a rainbow. So I said, what if I put this on a paper, so when I'm presenting this for the YouTube, people will understand exactly what happened. His name was Thomas Young. He was by far one of the greatest minds in history, because this is my opinion, after James Clerk Maxwell, his experiment changed the world, and it's called double slit experiment. Even Sir Isaac Newton was wrong about this because Dr. Young knew that, you know what, it's like, you know, sound. And most of the time when you study the physics, sound does the same thing. Reflection, refraction, and diffraction. So does this light. So Thomas Young did something like this, which was spectacular. So he had two small openings. It was, I have no idea, it was 1 millimeter or less. Then he realized he's shining light through this, and amazing thing happened, miracle happened. Those waves, they were interfering with each other. It was a great idea that, you know, light is electromagnetic. So he made those openings smaller and smaller and smaller. And of course, you know what, I had to move over here. So you can see maximum, minimum, maximum, minimum. They call this fringe. Anyway, he showed to the world that, you know, light is electromagnetic. And I have seen sometimes they see this double slit, you know, they just analyze, reanalyze. But this was great idea. I said, Vahan, why don't you try this with your own eyes? So I remember I did this in Denver again when I was doing my science thing. So I had a huge crystal here, and then it was a beautiful sunshine. It was one spot, it was a little bit, you know, I would say a little bit large, and then it was reflecting light so good. So I was so careful. I moved from right to left, and then left to right. I said, wow, thank you, Mr. Christian Huygens. You were right, because before him, Christian Huygens solved this problem. He was one of the greatest physicists in history, and in fact, we owe it to him. Galileo and the others, they knew what the pendulum did, but they never invented clock. But Christian Huygens, Dutch physicist, invented, and it was only 1 minute a day, which was amazing. But Christian Huygens' most important discovery was, you know, the reason why you see these changes or this is bent, because each one has a different speed. And he was absolutely right. Thank you, Christian Huygens. You were right. So I said, if I close my eyes, and then what I did, I had to replace my eyes with the double slit, Mr. Young's slits, and then my retina was this fringe things. And then when I did, I realized I'm seeing exactly. So I moved, let me read this here. My eyes closed with very small opening. Right to left, I saw like this. Violet, indigo, blue, green, yellow, red. And then I went the opposite side. I saw yellow, green, blue, indigo, violet. And I knew that, you know, my assumption when I was a kid, that was Mr. Thomas Young's experiment. Anyway, when I did this, I was happy, and then I realized, okay, there is another one. Let me see where that is. We have to get this one.